All right, we are in AP Stat. I am still in Unit 1, but we are looking at centers of measurement, and we just started on the idea of standard deviation. And we ended with this, basically trying to go over the different variations that we might possibly run into. So, again, this means sum. This is our sample mean that we're talking about, and this is the distance from it. So what is that other value minus the sample mean to find the distance there? And then we said that you square them. So you find each individual data set from the mean, right? You squared it each time. You add them all up. And then this is the sample minus 1. We do n minus 1 takes the total down by 1 and then makes this an overestimate for us. Okay. So if you don't completely understand that, keep in mind that the larger your denominator, the smaller a number will be, right? So what we want to do is we want to overestimate it. So if n is the sample size, and that's the largest that the bottom could be, then what we're going to do is we're going to take one away in order to make that distance a little bit bigger, just to guarantee that we get everything within our variation. If we divide by n, then the standard deviation would be smaller, right? The standard deviation would in turn be smaller. So what we're doing is we're trying to make the standard deviation as large as possible. N minus 1 makes a standard deviation bigger, and we can overestimate because we aren't dealing with population. Okay? We're not dealing with the population, so it's best that we overestimate. We also must undo the squaring at some point. Now, this right here, which is what we're going to get to, okay, we were discussing this idea. This is actually going to be variance. We didn't quite finish it. When we were going over this before on the last page, at the end of the last video, we were starting to develop it. I was trying to show you where standard deviation comes from. Granted, I understand your calculator will do this for you, but you still got to know why it is how it is. So we were basically saying that this is finding the difference between each one, but we want to make it positive, and that's why we square it. But then on top of that, we're finding the distance between them. We just went over why we are using n minus 1 with our sample. But what we are saying here is that we have to undo that squaring, because I just made it ridiculously large by doing it, and I squared it in order to always make that positive. So if I square root a square, they'll go away, right? If I square root a square, then they'll go away, which means I'd still get the same thing that's underneath, right? So what I'm going to do is I'm going to actually square root this whole thing so that that squared part goes away. So now we're all in different spots in our math journeys, right? Because some of us are coming from already taking calculus and some of us aren't. So if you had calculus already, some of you haven't, but I'm going to prove or show exactly why this works, all right? Other than saying that this is it, let's go with it, right? And we just put a square in there and we do it, but I'm going to try my best to get you to see where the standard deviation formula is coming from in the first place. There's actually another formula for standard deviation. Kind of looks like this. Okay? Looks a little more crazy, right? So, they will give you the same answer, this and the other one. This is saying, you know what? Find the summation of just that item, the first item, whatever that item is, squared, all right? And times that by whatever the sample is, minus find just the sum of all the values, and then square that item, and then divide that by the sample size times 1 less than that and square root it. Now, why would someone need another formula? Okay, so what we need to think about here is, why would somebody need the other formula? Well, notice a difference in this formula versus the other one. In the other formula I gave you, we knew the mean. In this formula right here, the reason why this formula is neat and it works to find the standard deviation is we don't need the mean. You don't need the mean at all, you just need the values. And you can calculate what the standard deviation is without it, which is kind of genius if you think about it. We don't need the mean, and you can still find the standard deviation. So if you want to pause the video and write that down so that you have the other formula, are you going to have to use these by hand? No. Is it nice to know that they exist in case they have some open-ended questions related to this? You betcha. So remember the bank example that I gave you before, right? You have the banks, and you have the bank 1, and each person was about the same. No variance basically whatsoever. This one has a little bit of variance, right? And this one should have a lot of variance from where it's at, but they all gave us the same mean, right? Let's look at bank 3. This is just bank 3, right? Just looking at bank 3. And let's try the standard deviation formula just to see what it looks like and what it works. It says, let's calculate the distance between each one and the mean. Remembering that we said that the mean of that sample was 6. So we're doing this minus 6, this minus 6, this minus 6. So that's the difference between each, right? Then, after you find the difference between each, we said, you know what, square it. So that's what I did. Square, 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 they're all positive. Then it said find the sum of them. Add them all up. There you go. I get 98, right? So next we can find n minus 1. Well, if there are 3 terms, subtract 1 is 2. So it's the 98 divided by 2, which is square root of 49, or 7. It's found the standard deviation is 7. Now, let me say that what we found is very rare, all right? A standard deviation is normally a decimal. Yeah, you guys got to remember that. You are not getting nice, pretty answers in this course. Hardly ever, okay? It just happened to work out that way. To prove it to you, let's find the standard deviation using the other formula. If we were to try this formula out, just to show you that they are the same exact thing, right? This says, you know what? Find out what your squared term is. So, there you go. Squared, squared, squared. Then you're supposed to add them up. So if I add up the totals, that is the total of x, and that is the total of x squared. Now the reason why I'm doing that is right here. It says find the sum of those and find the sum of that. Check. That's what I did. Found the sum of both. All right, and still n minus 2 and n, right? So we plug it in. N, that is 206 minus 18 is what we said that was, but squared. And then the 3 times the 2, which would give me this over 6, which when I divide gives me 49, which gives me 7. I get the same exact answer. I did not need the mean whatsoever. So it's just to prove to you that you will get the same standard deviation. And notice that they are the same. And yes, we will just use calculators for 99% of this course. All right? But I just wanted you to see it so you could see one time, plugging it in, how it works with a pretty simplistic example. Your calculator can do standard deviation for you, so you don't need to worry. And it can also find the quartiles and the means and the medians and the standard deviations. So the background legwork, your calculator will do for you. But I just wanted to show you that it does physically work. Now, let's use the calculator to take the data from the other bank, Bank 2, so you can get some practice with this. So the data from Bank 2, check. Press that. All right, edit. This was my list before, right? This is all the numbers we plugged in. So let's clear the column out, right? So remember to clear. I go highlight it, press clear, and enter so it all goes away. Check. Plug in a 4, a 7, and a 7. Check. Okay. Now that I have my data, I press the arrow. I highlight. I press edit and highlight over to calc. And this is a 1 variable because I only have 1 column, 1 variable that I'm using stat. I press enter. All right, I want to make sure it's in list 1, right? So it should be an L1 there. I press down to calculate. So I'll press the whole way down, press enter to calculate, and there we go. There is the mean that we found already, right? Look, it's telling me the sum of the x. That was in the 1 formula for standard deviation. Look, there's the sum of x squared. That's also in the 1 formula for standard deviation. All right, and this is what we're looking at right now. Sample mean is 6. Sample standard deviation is this right here because it's a sample. We'll get to what that is in a minute, hopefully, but that is the sample standard deviation. All right, if I keep scrolling down, I have the number n. I have the min, the lowest value. I have the max, the highest value. I have my first quartile, my third quartile. It even gives me the median. Everything is listed there. My quartiles and median are listed as well as the max and min. So let's compare the standard deviation from Bank 2 and Bank 3. Bank 3 had data more spread. It's a big number, so it's more spread. All right. Now, you may be asked to find the standard deviation for a population. And again, for a population standard deviation, that's what it's listed as, and we pronounce that as sigma. Okay? So if we were talking about a population, not only are you using a capital N when you're plugging stuff in, not only are you using a mu, which is Greek, right? And sometimes it's mu with a little X subscript with the line over it, but also for standard deviation, you are using the sigma sign. And again, right, population, mean, we use mu. This gives us a similar formula. So here's the formula. Standard deviation, square root. I don't need an n minus 1, I just need an n because it's the whole population that I'm using, so I don't need an overestimate. That is the highest that it could possibly be, so I'm good. All right, that x value is the value that you're trying to find the distance from. Mu is your mean in it. All right, in the sample, used n minus 1. It helped us overestimate because we were looking at just a sample, but now we are looking at the entire population, so I don't need to worry about an overestimate. I know the exact number of people. And if we use the entire population, we don't need to overestimate since everyone is included in there, and therefore we can be exact. Notice in the calculator when we did our last example, this is what we got, right? Remember that. It does distinguish between the sample and population for standard deviation. Variance, right? This is another way to show something varies other than with standard deviation, but it is not used as much. Sorry, just had to change that to show. Variance, right? Standard deviation is used basically all the time, okay? Now, so far, we've had population mean, and we've had sample means, right? We have variance, which is something else, but you'll notice that it's not on your list of your calculator, but it's simple to find. We have population standard deviation. We have sample standard deviation. We also have a population variance and a sample variance. Standard deviation is inherently based on your variance. We technically found variance when we were creating the formula. So it's already there. Variance is already there. Okay? And here we go. Here's why. If you calculate the standard deviation, then you already calculated the variance. Variance is the number you have before the square root. All right? Before you square root at the end. So, but point is, if this is our standard deviation, all I have to do is get the number right before. That's the population variance. And in order to get the population before, you basically just have to square both sides, and that's what will be left. The population variance is technically inside the standard deviation. The same here. It would be s squared. That would be your sample variance. And we are doing this just to get rid of that. So in the prior example, we said bank 3 had numbers 1, 3, 14, and we said that the standard deviation was 7, right? Well, our variance for that example would have just been 49 because that's what was there prior to the square root. In our other example, we said that bank 2 had the numbers 4, 7, and 7, and we said that that standard deviation was 1.73 roughly. Well, our variance for that was squared, which is approximately 3. So the point is, it was that prior. Okay? So here are our symbols for sample variance and population variance, so we can see those as well as the formulas. If you want to take this to write it down, I'm going to stop right here, and we can pick up with the rest of some of these notes when we get back.